Okay, hi everyone. This is Infinity YouTube channel. Please remember to like, subscribe, and share. So, I want to share another method or another procedure that you can use to calculate for your Z score, right? Your Z tabulated, as in the table of your Z. Okay, how you can determine that, right? From the question that we solved earlier, let me give you a recap, right? For those of you that have not watched the video, please, I will indulge you to go back and watch the video on parameter estimation. There was a different approach that I used, but let me give a recap on the first approach. So what I did at the first approach was that using this question, this was the question that we solved. So what we did earlier was we did, since it's 95%, since the percentage we have here is 95%, so what we did was 100. Okay, I'm going to compare the two methods. So we did 100 minus that 95% to give us 5%, rather, to give us 5%. And of course 5% is 5 over 100, which is 0.05. So according to the equation, because of is an interval, so what we did was we did Z of alpha over 2, which is Z of 0.05 divided by 2. Of course, we had Z of 0.025. So what we did after we had that Z of 0.025 was that we traced it on our T distribution table. Okay, so we traced it, and then when we traced it, since the total value that we had was 81, right? So the table that I brought, that is a T distribution table, stopped at 75. So what we did was that, of course, there's an infinite here, so I traced that infinite using this number 0.025. So when I traced it, this is my 0.025 here, so I traced it down, and of course I had 1.96 as my answer. That means Z of 0.025 using the T distribution table gave me 1.96. So that is the answer for your Z. So this was the method I used in my parameter estimation when I was trying to figure out my Z. So now let me give you the general and of course I would say the best method in order for you to determine your Z, right? So generally, for you to use your Z table, you must have your number of size greater than or equal to 30. If the question you are solving has the number of size that is greater than or equal to 30, you can just easily determine your degree of freedom. Are you there? You can easily determine your degree of freedom. So from the question that we solved, I'm still going to use the same question. From the question that we solved, we could see that our n, of course, was 81. So it is greater than or equal to 30. So the approach you are going to use is just the same thing, just 100% minus that 95% according to this question, since it's a 95%, right? Minus 95% will give us 5%. So, and 5% is equals to 0.05, right? So, and of course, what we are dealing with is an interval. Okay, so what you do, we are not going to use this Z alpha over 2. We are going to use Z 1 minus alpha over 2. So that Z1 minus alpha over 2, this will now be equal to Z of 1 minus 0.05 divided by 2. So if you should do that in your calculator, 1 minus 0.05 divided by 2 should give me 0.975. Now this 2 is only dividing the 0.05, not the entire Z. Okay, so when you have the 0.975, you go to your z table. So this is how the z table looks like. As you can see, you see you've some z here. See standard normal probabilities. This is how your z table looks like. And if you look at here, you see your z, right? So this 0.975, you are going to look in between these values inside this box, not this vertical column that has your z, but the one that all these numbers that are inside of this box. Look for 0.975. So from here now, what I'll be looking out for should be my 0.975. So let me look here, because I have 0.975. Yeah, I can see that. So that you can see 0.9750. 0.9750 means 0.975. So trace it here. This is 1.9, right? Good. So trace it up. This is 0.06. So 1.9 plus 0.06 is giving me 1.96. So this is also equals to 1.96. As you can see, any table that you are provided with, you can easily solve for that. So the only difference between when you want to use your t table is that you are not going to subtract 1 minus alpha. You are just going to divide it by that alpha. But in this situation, you subtract 1 minus alpha and you get the value of your z. So you can do that. Okay, you can do that. So try this and drop your answer on the comment section. Try for 1%. Try for 1%. Try for 10%. Let's see your answer. So for you to try for your 1%, okay, let's